everyone. My name is Sonia Lamba, Assistant Professor, ABES Engineering College. Welcomes you all in the lecture series of computer networks. In the previous lectures, we have discussed about the content we will cover in the unit second, data link layer. And today we will starting with the very first lecture. So in today's lecture, we will discuss what is error detection and correction. We will discuss the types of errors and some more topics. So these are the topics that we are going to cover today. So we will discuss the types of error, single bit error or burst error. We will discuss what is the redundancy and how it is achieved. Next is the detection is versus correction, how the error detection is different from the error correction. Next, we will discuss the forward error correction versus the retransmission. What is the difference between these two? And we will discuss the various techniques that will be used for the error correction and detection. So first, we will discuss the position of data link layer in the OSI model, OSI reference model. So if talking about the position of data link layer. So data link layer receives the data packets from the network layer, and after attaching the header as well as trailer, passes on the frame to the physical layer. So this is said to be a frame when we are attaching the header as well as the trailer. Header contains the addressing information and some additional information as well, and the trailer we are attaching for the error detection and correction purpose. A trailer contains some of the redundant bits with the help of which at the receiver end, the receiver will be able to identify whether the receiver has received the corrected data or the corrupted data. So at the sender side, the sender is encapsulating the data packets. Sender is attaching the header as well as the trailer, and then passes the data to the physical layer. And it's the responsibility of the physical layer to transmit the data across the channel. And at the receiver end, physical layer passes on the data to the data link layer, and data link layer's responsibility is to remove the header as well as the trailer, and based on the trailer, detection will be happen by the data link layer whether the receiver has received the corrupted data or the correct data. And if the data is corrected, then the data link layer passes on the data to the network layer. This diagram actually illustrates the position of the data link layer in the OSI reference model. So today we will start with data corruption. So data can be corrupted during the transmission, as we have already discussed in the previous lectures, that the medium that we are using for the transmission of the data is not perfect. There are various causes of the transmission impairment. It can be the noise, it can be the attenuation due to the distortion as well. The data will be corrupted while the data is transmitting from via the channel. So but some applications are there that requires the reliability. So for that purpose, we need to detect and correct the errors, or we can say we need some method or the mechanism via which the receiver can detect and correct the error, so as reliability is required. So if we will discuss the types of error, so there are basically two types of error: single bit error and burst error. Now we will discuss the difference between the two, single bit and burst error. Now, in a single bit error, there is a change only in the one bit. Like in this diagram, we can see the sender has sent this data, but during the transmission, this 0 bit has been changed from 0 to 1, and receiver received the corrupted data. So if there is a change only in one bit, then we will say the error is the single bit error. So if only one bit in the data unit has changed during the transmission, error is called single bit error. But in burst error, if more than two bits are corrupted, then the error is called the burst error. Or in this case, we can calculate the length of burst error as well. So length of burst error is the measurement from the first corrupted bit to the last corrupted bit. So in this diagram, we can see first corrupted bit to last corrupted bit. The length is the 8 bits. So the length of burst error here is 8 bits. So if two or more bits will change during the transmission, then the error is called the burst error. So sender has sent something else, but the receiver has received another data, because during the transmission and the medium is not perfect, some bits have been changed from 0 and some will change from 1 to 0. So this is called the burst error. Next, we will discuss the redundancy. Redundancy is to detect or correct the error at the receiver's end. Sender will send some extra bits called the redundant bits with the data. And at the receiver's end, the receiver, with the help of this redundant bits, will be able to identify whether the data is corrupted or whether the data is correct. So these redundant bits are added by the sender at the sending end and will be removed by the receiver at the receiver end. So this is called redundancy, where we are attaching some redundant bits with the data. So now we will discuss the error detection versus error correction, which one is more difficult and which one is easier comparatively. Talking about detection versus correction. So correction is more difficult than the detection, because in detection we are looking only to see if any error has occurred or not during the transmission. We are just concerning whether there is a change in the bit or not. But in case of error correction, we are trying to identify the exact number of bits that have been changed from 0 to 1 or from 1 to 0, or we can say the number of bits that have been corrupted during the transmission. And more importantly, we are also concerning here the location of the bits that are corrupted during the transmission. So obviously error correction is more difficult comparatively to error detection. So next we will discuss the forward error correction versus the retransmission. So there are two main methods of error correction. First one is the forward error correction, and second one is the retransmission. So in case of the forward error correction, the receiver tries to guess the message by the redundant bits added by the sender. With the help of these redundant bits, receiver will identify whether the message is corrupted or whether the message is correct. But in case of retransmission, the receiver detects the occurrence of an error, and if the receiver detects that the error has occurred during the transmission, so in that case the receiver will request the sender to resend the message again. So this is called retransmission. Sender is requesting for the retransmission of the frame. So next we will discuss the various error detection and correction techniques. First one is the single parity check. Next one is two-dimensional parity check. Next we have checksum, then CRC, and then Hamming code. First four are the error detection techniques. These are the techniques via which we can detect the error, but we cannot correct the error. But Hamming code is the technique via which we can correct the single bit errors as well. So in the next lectures, we will discuss these techniques of error detection and corrections one by one. We will solve some numericals as well based on these topics. So this is all about for the today's class. So this is the reference. Thank you, everyone.